Car crash investigation by Danae, Sarah, and Marissa. We are investigating a traffic accident that occurred in a 35-kilometer-per-hour speed limit zone on Tequila Road. A 3,000-kilogram Cadillac Escalade SUV rear-ended a 2,000-kilogram Subaru Outback wagon that was stopped at a red light. We were asked by the investigating police officer to determine what happened and what traffic laws were broken.
The diagram shows the situation that occurred. The wagon was stopped here. The SUV came from behind, hit the wagon, and skidded 2 meters, traveling 2.828 meters per second at negative 2 meters per second for every second. From the impact, the wagon skidded 24 meters, traveling 12 meters per second at negative 3 meters per second for every second.
To find the initial velocity for both vehicles, use the velocity squared equals initial velocity squared plus 2 times acceleration times the distance traveled. The final velocity for the SUV is 0. We are looking for the initial velocity. The acceleration is negative 2 meters per second for every second. The distance traveled is 2 meters. The initial velocity is 2.82 meters per second. You use the same formula for the wagon. The final velocity for the wagon is 0. We are looking for the initial velocity. The acceleration is negative 3 meters per second for every second, and the distance traveled is 24 meters. The initial velocity is 12 meters per second.
The momentum flow chart shows the mass and velocity before and after the collision for both the SUV and wagon. Momentum is mass times velocity. Since momentum is conserved, both sides can be set equal to each other. 3,000 times velocity plus 2,000 times 0 equals 3,000 times 2.828 meters per second plus 2,000 times 12 meters per second. Combine like terms to solve for the velocity. The velocity before impact is 10.828 meters per second.
To determine whether the SUV was speeding when the accident occurred, the speed of the SUV had to be converted to kilometers per hour. We had to set up a conversion chart. There are 60 seconds in a minute, 60 minutes in an hour. Multiplied 10.828 meters by 60 by 60 divided by 1 hour. The SUV was traveling 38,980.8 meters per hour. To convert to kilometers per hour, the decimal point was moved 3 spots to the left, the same thing as multiplying by 1,000. The SUV was traveling 38.9308 kilometers per hour in a 35 kilometer per hour zone. The SUV was speeding at the moment of impact.
When determining the type of collision, kinetic energy has to be looked at. The formula for kinetic energy is kinetic energy equals 1/2 mass times velocity squared. The mass for the SUV is 3,000 kilograms. The velocity before the impact for the SUV is 10.828 meters per second. The kinetic energy for the SUV before impact is 175,868.376 joules.
The mass for the SUV is still the same after the crash, 3,000 kilograms. The velocity after decreased due to the force of the wagon acting upon it, which is 2.828 meters per second. The kinetic energy after the crash for the SUV is 11,996.376 joules. You use the same kinetic energy formula for the wagon. The mass of the wagon is 2,000 kilograms. The wagon was stationary before the collision, therefore the velocity is 0. Since the velocity is 0, the kinetic energy is 0 as well.
The mass for the wagon is still the same after the collision. The velocity increases due to the force of the SUV, causing it to be 12 meters per second. The kinetic energy after the collision is 12,000 joules. Since there are 2 kinetic energy values for before and after the collision, you add them together. 175,868.376 joules does not equal 23,996.376 joules. Since kinetic energy is not conserved, the type of collision is inelastic. The SUV work energy diagram shows the kinetic energy and work done to the SUV. The SUV starts out moving before the crash, therefore it has positive kinetic energy. At the moment of impact, the SUV slows down, causing it to lose kinetic energy, which means the work is negative. Since the work is negative, the kinetic energy with brakes being applied is less than the initial kinetic energy, but is still positive. The work being done when the brakes applied is negative due to the SUV stopping. Since the work is negative, the final kinetic energy is zero because it is at rest.
The wagon work energy diagram shows the kinetic energy and work done to the wagon. The wagon starts out at rest, therefore the kinetic energy is zero. At the moment of impact, the wagon speeds up, causing positive work. Since the wagon is in motion, it has positive kinetic energy. The brakes are applied, causing the work to be negative, which cancels out the kinetic energy. So the final kinetic energy is zero because of rest.